I am Paolino Caputo. I obtained my PhD in Life Science and Technology from the University of Calabria, Italy. Currently, I am a postdoc researcher in the Department of Chemistry and Chemical Technology at the University of Calabria. Currently, I have 30 publications with over 70 citations. I am also one of the inventors of the anti-smoke for bitumen patent. Today, I will talk about physical chemistry evaluation of a new green additive for bitumen. This work explores the potentialities of a class of lipophilic food-grade additive in solid and liquid form, non-toxic and eco-friendly biocompatible compounds. We call LCL a liquid additive and LCS a solid additive. These additives are a surfactant, and they react chemically with the bitumen, and for this reason they change the physical chemical property of the final binder. Sample preparation. Both additives were mixed separately to hot bitumen in the following wet percent ratio: 1, 3, 4, 5, and 6. The bitumen was modified by using a mechanical stirrer. Firstly, 100 grams of bitumen was heated up to 140-160 degrees until it is fully fluid. Then a given amount of additive was added to the melted bitumen under a high-speed stirrer mixer. Furthermore, the mixture was stirred again at hot bitumen for 30 minutes. Sorry, I have a problem with the presentation. Okay. To determine the transition temperature, rheological measurements has been done. In particular, the dynamic temperature ramp test from 25 degrees up to 100 degrees at rate of 1 degree per minute at frequency of 1 Hz were performed on all samples. In this picture, we show a semi-log plot of temperature ramp tests for the pristine and modified bitumens formulated with 1/6% of the additive. The effect of inert filler, calcium carbonate, was also determined for evaluation of the effectiveness of the additive on the bitumen. In general, a good modifier agent increases the transition temperature of the bitumen. We observe that the transition temperature increases with the percent of additive, and we see in LCS case, the shift of the temperature is around 70 degrees in comparison of the bitumen without additive. While in the LCL case, we observe one increase of 25 degrees in comparison with the pristine bitumen. It's very important we observe a sort of a buffering effect. This is a typical phenomenon of the modified bitumen with the polymer, the elastomeric polymer. For this reason, this result is excellent because the rheological behavior of the modified bitumen with the new additives is very similar to the rheological behavior of the modified bitumen with the polymer. To evaluate
полімером. А потім ми чекаємо, ми будемо розходити два методи. Тест на кипіння.
Millimeter. The aggregate is a stone having acid chemical nature, quartz porphyry. The boiling test procedure used in this study was according to STM normative. In particular, the sample was placed in the boiling water for 10 minutes and then cooled to room temperature. The water decanted and the sample let dry on a paper towel for 1 day. The degree of bitumen coverage in patient was rated by visual observation. This is an empirical test, but is very used in the road industry because it's very easy and it is very fast. In this slide, we show the results about the boiling test. The pristine bitumen have a bad adhesion with this stone, where when we used the additive, solid or liquid, we strongly improved the affinity between the bitumen and the aggregates. In particular, with a dosage higher than 1% the additive, the covering is almost complete. While we don't have significant improvements with the dosage higher than 1%, for example 3%, looking at the performance of percent of the additive. Contact angle method involves the use of the pendant drop tensiometer. All aggregates were suitably cut to obtain a smooth surface, washed with water and dried at room temperature for 1 day. Subsequently, using a needle, 3 drops of hot bitumen for each sample were performed. We put hot bitumen at 150 degrees on the surface stone. The stone is at room temperature. The contact angle measurement has been made thorough following steps. Step 1, the sample kept at 25 degrees. Step 2, the sample were kept for 10 minutes in the oven at temperature 25-30 degrees higher than the ring ball of the bitumen. Step 3, the sample kept 2 hours in the water at temperature 5 degrees less than the ring ball of the bitumen. All measurements were carried out at room temperature. To evaluate the adhesion, the difference between step 3 and step 2 is calculated. We have a good adhesion when the contact angle step 3 and step 2 is equal or very similar. Greater is the difference between the 2 steps, worse is the adhesion. Because in the step 3, the effect of the water with the melted bitumen increases the angle if there isn't a good interaction between stone and bitumen. While in the step 2, we record a lower angle, better adhesion, because the sample is prepared in optimal condition without water. These results showed in the table confirmed that the additives, solid and liquid, are excellent adhesion promoters, and they are similar to the boiling test results. In particular, the results of a liquid additive are excellent in comparison with the pristine bitumen, and they are better in comparison with the modified bitumen with the solid additive. In order to study the effect of aging in the laboratory, the method now as a rolling thin film oven test was adopted to simulate the short-term aging of asphalt binder that would occur during the hot mixing process. The apparatus consists essentially of an internal double-wall furnace in which the hot air circulates conveyed by an internal fan at the test temperature of 160 degrees. The test consists in subjecting a thin layer of bitumen to a hot air jet for 75 minutes. Each modified bitumen plus a reference binder free of additives was divided in 2 aliquots. of which only one was subjected to the process of artificial aging. To evaluate the effectiveness of antioxidant agents, the rheological measurements were performed before and after aging. In general, a good antioxidant agents were thus not change the viscosity property and the transition temperature after aging process. In this result, we observe that the pristine bitumen, when is aged, shows higher transition temperature, around 70 degrees, in comparison with the pristine bitumen no aged. We have the best results when 2% of the solid additive is added to the bitumen. In fact, the shift of transition temperature after aging is lowest. So the use of this additive reduces the aging of the binder, extending the life of the rod pavements. In this case, only the solid additive can be considered as a good antioxidant agent because the liquid additive does not enhance significantly in improvements. In conclusion, the analysis of bowling, contact angle, and the time rheological measurement confirmed the effectiveness of the food additives acting both as adhesion promoter, as rheological modifiers, and as antioxidant agents. We can see the LCL additive is the best as adhesion promoter and modifier agent, while the LCS additive is better as antioxidant agent. Thank you for your attention. I'm finished.
Дякуємо, Паоліно. Вам є питання, яке стосується, як ви дослідили нетоксичність добавки?
Sorry, but I don't understand. Can you repeat?
Яким чином ви дослідили нетоксичність добавки?
The non-toxic that this addition is not toxic.
It's not toxic because this product derived about the food industry, because it's the waste of the food industry. In particular, if the oil soil is after the treatment about the for the production of the oil soil for food grade, there is this waste. And this waste, for this reason, it's not toxic because I have analyzed this, and the components, the typical components, can you found in the normal food grade additive. It's not food grade additive because it's not pure, but there is the other substance, not toxic. It's not good for food grade, but it's good for road pavements industry because it's not toxic, and I don't have a problem for the use in the road pavement industry. So.
Зрозуміло, дякуємо.